Evening, wherever you may happen to be, and whether you're watching live or archived, and welcome to Season 2, Episode Who Knows What of the Nautel Transmission Talk Tuesday webinar series. I told Ed before we started that we definitely want to give a shout out when we hit 50 of these, which I think will be in a couple of weeks, so stay tuned for that. Today, we're going to talk about RBDS, RDS, whichever you prefer to call it, radio data systems, radio broadcast data systems. And to do this, I've got an awesome guest, good friend and worthy competitor and cohort and occasionally drinking buddy here and there, but Tony Scott Peterle from WorldCast Systems. Tony, welcome and thanks for being with us today.
Thank you very much. It's a pleasure to be here, and a drinking buddy here and there and everywhere.
So we both spend way too well in pre-COVID days. We spent way too much time on the road. That's gone totally away. Although I know we're getting ready to get back out there soon, and I think you were in an airport fairly recently.
Yeah, I actually got to travel out to San Francisco in February of this year. Had to get a special dispensation letter to do an update on our Sutro project. We got the RF control and monitoring project for the Sutro antenna installation as part of the repack, and so it's been a great project to be able to work on, an iconic site to visit, multiple times, and one of America's great cities too. San Francisco is the bomb.
You got that right. It's always cool too when you're standing up on that hill and you're looking down, and the way the clouds come in. Some days it looks like you could almost step off the mountain and onto the clouds. It's a really cool.
Yep,
So,
fascinating place, technically and meteorologically.
Yeah. Now, on a little more serious note, just I want to do a quick shout out. We heard they just wanted to offer some sympathy to our friends at BW. We heard about Scott Inks this morning, and that's this industry, we all compete, but we're all friends, and we've just been hanging around for so many years.
Right. I've been friends with Scott for 7 or 8 years now. We collaborated some years ago, rebranding his audio processors when he was just making his entry into the U.S. market. And so we got to work together with him on some projects there, and then later on as competitors. And he was always a character, always a great person to see at the shows. Him and his late partner Roger. Swapping stories of their pirate days in London, years ago on our first meetings. And some of my favorite, broadcast stories ever. Is just an amazing, talented, brilliant engineer and a hell of a guy.
Yep, exactly. And I mean, these days we see too many notifications like that, but I saw that one this morning, and Scott's been a good friend for years too. So I just wanted to give that shout out. On that note, picking it up a little bit, because there we go. I started with a kind of a downer. I apologize, folks.
Well, it had to be said, he was.
And my mind is a rabbit hole, and whatever comes through it is going to come out. Sorry about that too. But mandatory housekeeping stuff. This webinar, as with all of our webinars, do qualify for half a recertification credit under the SBE category I of the recertification schedule. If you're an SBE member and you're not certified, you should be. And if you're not an SBE member, why not? There are some significant benefits. Shout out to Wayne Pacina, the SBE president. I see him in the audience. And on that note, we do make these as interactive as we possibly can. So you've got a place there you can type in questions. We will certainly address them. Ahead of time, when you registered, there was a chance for advanced questions, and I dutifully printed that out. I will try to remember to address them all. I sent a copy to Tony, so hopefully the ones I miss, he'll remember. We'll just go through this and have a lot of fun. If you want to, you see the little hand wavy icon on your control panel. Click on that. If you've got a microphone, we're happy to unmute you and make you part of the conversation. I'd ask you to keep it PC just because Ed's recording it. Mr. Disembodied Voice in the background makes sure that we all do things the way we're supposed to. Nobody's ever really defined the rules, so that also heads to the fun. So this is a new slide. This is a surprise for Tony. This is just the kind of things that we're going to look at. But the big thing, and one of the biggest calls we get, and I'll be the first to admit that I think our handbooks could use some improvement in the area of RDS. We talk about all the fields and what they are, but we don't really talk a whole lot about what they do and what you can get away with and what you absolutely must have. So we'll try to hit that. And then, Tony, this is one of the reasons I asked you to do this, because the FMB 80 is probably one of the most common RDS generators in the field, one of the most popular. And we've got a couple of slides talking about, because you guys retired that last year, correct?
Yep, I had a long, I think it was 30 plus years in the trenches, the FMB 80, and really was the first encoder in the US to get widespread use that could do all of the things that RDS can do, because there's a whole lot that goes on behind the scenes besides just simple artist and title information. So it was, very high quality product, and that was recognized early on by early adopters like Gary Klein and some of the other broadcast groups, Clear Channel at the time. Saw that it was delivered a good quality composite signal and had all the capabilities plus more that they could ever think about using. So we were very fortunate. That was kind of our introductory product to the U.S. and has served well over years. But component obsolescence gets to all of us at one point or another. So yeah, we do have a new RDS encoder worthy replacement for the FMB 80, and I think we've got a slide or two on that a little bit later on to show you some of the features. But there's a lot of manufacturers in the business, so many options obviously besides ours.
Right, and yeah, obviously I bring yours up just because the FMB 80 is such I guess a legacy type product, and your official title, I saw somewhere it had technical in it.
Well, yeah, I was hired as the technical support manager for the U.S. office, the first U.S. technical employee for the company. This is back in 2005. I was living in Seattle at the time, so drove my beat up old 1980 Ford Taurus from one corner of the country to the other. And about a year after I arrived, it threw its transmission out on Biscayne Boulevard, and I bought a convertible because I'm a Florida guy now.
There you go.
So yeah, came to work for the company in 2005. One of my first jobs was to rewrite the manual for the FMB 80 because the one that we had translated at the factory in Bordeaux was in what we affectionately call franglais. So it helped to have a fresh take. And so I really had been in broadcast engineering for decades prior to that, but really hadn't dealt much with RDS. So I started kind of learning the technology from scratch myself at that point.
And just on the topic of convertibles, you have got one that you've been restoring more. I think you're on the second iteration of restoring Genevieve, aren't you?
She's definitely on her second life. Yeah, Genevieve is. I wish I had a photo handy.
I meant to put one in and I totally forgot. So you'll have to refer to Tony's Facebook page for that. But
that's right. Yeah, no, Genevieve is an old British roadster, an MGTC, 1947. I fell in love with the look of those cars when I was a little kid, and when I was in college, my dad saw one for sale in the paper that was a partial restoration, and looked it over and bought it. And so he and I spent about 3 years putting it back together. That was back in the early 1980s. So owned that car for a long time, and in 2013, I got to realize a lifelong dream and drive it from Ohio down to Florida, 1,300 miles in a 70-plus-year-old car. It was an exciting adventure for sure.
Wow. Getting back to the RDS, I grabbed a screenshot from the RDS tabs on our website, and there are a lot of fields there.
Sure.
And this comes back to what applies and what doesn't apply. And one of the, I'll hit a lot of the questions. We'll probably leave this slide up for a little while we talk about it. And then I've got some other ones that you've got on. So if there's any of the ones you got that you want to refer to, let me know. I don't mind skipping back and forth too.
Okay, no worries.
But the big thing that I run into probably the most is how do you get the data from over there to over here? And somebody had specifically asked that they connect to the site with a Telos ZIP1, a ZIP1, and can you transfer the metadata via that?
Yeah, if the ZIP1 has a serial path that you can build into the connection, then yeah, absolutely, you should be able to send the data over that. But you've got IP connectivity to the site already if you're using a ZIP1. So, the RDS data doesn't necessarily have to flow through the codecs. You could find a side path, either TCP, IP, or UDP, or using serial over IP converters, to keep it independent. Because then if the zip, goes away for whatever reason, you don't also lose your RDS.
Right. And that's one of the things that is worth mentioning. And you see on the top one of ours, we've got data source. And depending, I mean, the data could be ASCII text. It could be the UECP2 RDS format. That's kind of an Innovonics thing, isn't it, Tony?
No, UECP was a standard developed early on, kind of coincident with the RDS standard itself.
Okay.
Because as they were putting the RDS standard into place and all the different countries in Europe were rolling out, a lot of different manufacturers were getting into the RDS game. And
Mhm.
so it was deemed important that there be some sort of universal way, because all the different manufacturers use different commands to do different things. And
Right.
so universal encoder command protocol was just that. It was a
Hmm.
common language that you could use to address and send data of various types to encoders from any manufacturer.
Good deal. And again, as you said earlier, you can send it by a serial or in this case IP. This is the for what it's worth, this is the little 1 kilowatt at the station that I play at in my infinite
Oh
spare
yeah,
time.
and
And
it's also important to delineate that if you're sending over IP, that can be either UDP or TCP, which
right.
are different flavors of connectivity.
Now, the one critical thing, if you are sending over IP, and this one I've run into a lot, is that you do typically have to specify the port destination of the destination IP address.
Correct.
So like for us, for example, your automation system would have to point to the transmitter IP semicolon 7005, which is
Yep.
the port that we use.
Yeah,
You
that's
know,
actually
so
one of the default TCP ports for our equipment as well.
yeah.
Um, So yeah, typically, depending on the software in the target device, you can specify a different port number, or TCP also TCP/IP to port 23 is what's
Mhm.
commonly called Telnet. And
Right.
so, if you're sending TCP/IP commands, it's actually one of the diagnostics that I do when I'm troubleshooting, is to see if their automation, the computer with the software that's sending the commands, if that computer can initiate a Telnet session with the encoder and send data on port 23, then at least
Mhm.
we know that the network pathway is correct and some of the ports are open.
Right. And I mean, that's the same thing. Like one of the things that we've got now in our latest, and I forget where it is, it's on this page somewhere, but there is the ability to echo to the local host. So we can actually show in the latest iteration of software the RDS on the screen. And that's something that your new product does as well that we'll talk about, which is kind of cool. Being able to actually see that you're getting the data.
Yeah, that was an important troubleshooting thing. I was very happy, to have spent so much time with our customers and with the FMB80 for so many years, so that when it came time to design the new RDS encoder, there were several specific things that I knew had to be in there, and that's one of them is what we call the
Mhm.
debug pages, where you can actually see the raw data coming in from your software and be able to debug the syntax and again ensure that at least the communication path is functional.
Right. And that's speaking of the communication path. So one of the most common things we'll get is people saying, so I've got this all hooked up and I kind of think it's working, everything seems okay, but I don't see it on my car stereo.
Mm.
And a lot of times you'll go in and you'll discover that the PI code is blank.
Yep. There's a lot of people don't kind of understand the function of the PI code, and that there are certain PI codes. For example, the standard F000 indicates to a receiver, RDS receiver, that there is no station there. So
Mhm.
some tuners, particularly from European car manufacturers, if they're scanning the dial and they hit a station with a PI code of F000, they won't even stop. They won't even tune to that frequency.
Mhm.
It's the variety, variation of how different receivers deal with RDS data is staggering. It was one of the first kind of jaw drop moments when I first started working with RDS. Is how differently receivers from different manufacturers, or even different models from the same manufacturer, will handle
Mhm.
and display RDS data.
And that's critical, right? Because I mean, the Dodge truck that I just replaced recently, if it hit a station that had and our default's 4 zeros for the PI code, but either way, if it hit a station where there was no PI code set, it wouldn't display RDS at all. My current truck will display the PS name, but won't display anything else on an all zero.
If there's no PI code set, and even a PI code with a 0 in certain places can indicate an emergency indication or some kind of different type of RDS handling that the receivers have to follow. So it's there's a lot of little gotchas about the PI code, including, and this was one of the questions we had on the sheet, is having in the US, of course, the PI code is derived typically from the call letters. It's basically a 4-digit addition problem in base 26. So, but there are lots of little tools online that you can use to look up your PI code. But there are exceptions because sometimes that mathematical operation generates a PI code with a 0 in the second or third slot, and that flags the receivers to do something bizarre. And so they have to make special exceptions for those. The 3-letter calls, stations with 3-letter calls, those PI codes are all written by hand, essentially. They just pluck one that nobody else is using and say, okay, this will be. There's a way to calculate that as well that doesn't conflict with the others. And some stations are implementing TMC, the traffic messaging channel, which is one of those kind of behind the scenes RDS functions that we'll talk about in a little bit. But the way the method of TMC they were using required a PI code that started above a certain number. And due to that fact, all of their stations are below. I can't remember. There was something about the first digit of the PI code, and essentially meant that all of their stations, either east or west of the Mississippi, had to use a modified PI code. They couldn't use the one that was generated by their call letters because it would screw up their TMC data.
Going to say either the K or the W. One of them's going to forget about the Canadian Cs. So that is a question, and Kirk Nisbet's asked this in the questions here, and it was one of our advanced ones from Lawrence Galkoff. What's the best way to ensure that broadcasters enter the PI code? And that's a really loaded question.
Right.
From the manufacturer, and it's really not something we can do. I mean, there's a certain amount of
we can't force somebody to adhere to the regulations. And the PI code is really kind of more of a guideline in the US. And on the rest of the planet, the PI code identifies a specific program, the audio that you're listening to. Here in the US, it's loosely tied to the call letters, but there are lots of different exceptions. So the general rule of thumb is if you're not screwing with anybody else, right? If you're using a PI code that's unique to your broadcast area, that's really about all the further the authorities care about it.
So, and that is something to, like translators, you can generate a PI code, and there's a link on resources at the end, because a lot of people use w9wi.com, which is a great source for looking up RDS info and a lot of other radio broadcast related stuff. I mean, Doug's done an amazing amount of work with that website, but it will only do a 4-digit US call. And if you've got a translator, it won't generate the PI code for that. However, I've got a link in the resources to the NRSC standards, which does include a PI code generator for translators.
The practical side of translators and boosters is that if they're playing the same audio as the primary station,
that's the code they want to see.
They should carry the same PI code, because then if translator, you can use the alternate frequency switching built into RDS, so that receivers that are so inclined can just hop from main to translator back and forth because they see it's a stronger signal with the same PI code.
That's a whole different discussion that we'll get to in a second too, because some receivers don't play well with alternate frequency, especially in North America.
And North American manufacturers, generally something you have to go into a specific menu and enable. But again, we can talk about that later on.
And that's something William Bowen had asked the exact same thing. For an FM that's rebroadcasting an AM, would the PI code be for the translator call or the AM call station? And it's really not an FCC requirement either way. It's kind
Nope.
of a, what do you want to do to identify, you know, how do you want to market your station?
Right, and the AM doesn't have a PI code, and even if it did, there'd be no way to use the alternate frequency switching. So, you know, translator for an AM, you can kind of wing it based on the translator calls. But again, if you just program in something in there that's not one of the red flag PI codes and is unique to your broadcast area, pretty much nobody's going to care.
Mm-hmm. And Chris Hayes mentioned that he used his Grundig portable with RDS, and it said a station was mono, and discovered that the one of the parameters had a well, and you can see it here,
Yep.
just the very last field we've got. But yeah, one of the bits in one of the fields identifies whether you're stereo or mono for some reason.
And also whether it's music or speech, or whether it's artificial head, and you know, there's a whole lot of settings there that, you know, in practical terms, I don't know that they do a whole lot of anything,
Right.
unless you have like a special RDS receiver that's going to display those actual flags. Most of the consumer receivers are not even paying attention to those. I don't think.
Now, where they do come into some benefit, the PTY code.
Yes.
If you've got one of the more recent smart receivers, you can search by type.
Right, and it's
And,
format type. Program type code is essentially the format of the radio station, and there are, even back since the beginning, because PTY has been part of RDS since the early days. So there have been receivers since early on that you can search for rock or top 40 or news or sports or whatever, whatever the format is that you want. You got to watch that the codes are different though. The RDS standard and the RBDS standard, different number of codes mean different things.
Right, and that's worth mentioning as well. Now, the other thing, flicking back to the beginning, so after our PI code, we've got the PS name.
Right, program service name. That also is one of those things that is vastly different in the Americas than it is in the rest of the world. In Europe, you know, the early days of RDS and still the standard in many countries is the program service name should be just the name of the program, and it should be 8 characters, and it should not change. This is the field that is displayed by default on most car radios, and it was determined that scrolling or changing that every few seconds would distract the driver, cause them to look down at their dashboard to see what it's saying, and take their eyes off the road. So in many parts of the world, changing that PS code is forbidden. You're not allowed to do it. And that was the standard at the beginning. In fact, early on, when I was trying to understand the behavior of different kinds of radios to RDS, I actually called and got through to one of the design engineers at Delphi, which is the electronics company that built the OEM radios for GM cars for decades. And he actually sent me a receiver of the era, and you know, he and I talked on several occasions, and he told me that their design criteria for the PS code in the early GM receivers was that if they saw that PS code change in the data stream coming from the broadcast, their assumption was that it was a mistake, that it was an error or some kind of interference. And it wasn't until they saw the complete new 8-character PS code in the broadcast 3 times that they would acquiesce to actually change the display on the radio. And so a lot of stations that were doing scrolling PS, where that 8-character display is updated every few seconds to display more and more of the artist name and the song title, if they were changing that too quickly, the receiver would never accept the new 8 characters. It would, you know, it would glitch, half the display would change, and it was just a mess. So you had to slow down the refresh rate on those 8-character screens to a rate that the receivers would accept.
Yeah, and that's worth mentioning. I mean, this particular display, our software, we handle the dynamic program service, the scrolling 64 character. And we won't even get into the concept of throwing album art as a distraction on the display, but that's a whole different discussion.
Yeah.
So Joe Fleming has asked, what if you have a PS code that is 9 characters? And these days with current software, again, you can do dynamic PS, so you can have up to 64 characters.
Yeah, you could display the first 5 and then the last 4, or the first 8 and then the last 8. You know, the display is always going to be 8 characters, but you can you can update it to put longer messages on there.
Yeah. Now, in the case of our station, we put the 8-character, well, 7-character for us, but who's counting? And we turn the scrolling off. We just leave it up as a static display.
Right.
And that's the other thing to remember. Different RDS encoders, whether it's in a transmitter, whether it's us, whether it's somebody else, whether it's in a sidechain RDS generator or a software RDS generator like the Arctic Palm product, they all react differently with respect to how they scroll. And like for us, I mean, you can set scrolling by word or by character, and then you can set the scrolling speed. And I do word fast, and it is incredibly slow. If it was on by character and slow, it'd take 2 days. I mean, the song would end before my 64-character message got across the screen.
Exactly.
So that's more a caveat, not caveat emptor, but just be aware of what you've got and how it works. And Laverne had asked a question. Then Laverne's out in central Canada, but they've got, and I'm going to have to scroll up just a little, so bear with me because I've got too many buttons and not enough brain cells. They use a WorldCast Silver at the mother station and an Innovonics Aaron 650 at a translator. RDS is set to regenerate in the 650, but the RDS performance is very sketchy. Receiver signal is solid and clean. Any ideas on what to look for? And the first thing that comes to mind to me is phase.
Yeah, that's a possibility. But I think what he's saying is that the RDS data they're receiving in the Aaron to be regenerated is weak. I'm not sure. Check the injection level. I'm assuming the silver is the primary. He said.
Yes.
So, make sure the RDS injection level is sufficient, and check the reception at the place where the Aaron is with another RDS receiver, perhaps.
No, the received RDS is good, he says.
Oh, the received RDS, but what's coming out of the Aaron is not so great.
So, I mean, definitely injection level, and I say phase is, and we'll talk about phase in a couple of slides too, because that's one of them. We'll get into the whys of that in a moment.
Yeah, and just for clarification, we're talking about the phase relationship between the 19 kilohertz pilot and the 57 kilohertz subcarrier.
Right, which coincidentally is right on the third harmonic.
Exactly.
Now, so that and the injection level are really the two big things, but it also does come back to what you were talking about with the refresh rate early on. And I'll just pick an example with one of our transmitters, because the VS, what this particular screen's taken from, has a fairly limited ARM processor to handle all this stuff.
Right.
And if you hit it with too much data too fast, it just looks at it and goes, nah. And you may get a character or two, you may get the title for this song, but not for the next song. You may get a word here. It can be totally sporadic if you overwhelm that ARM processor. And the reason I bring that up, because one of the automation makers that I've got some really good friends with, and we've had this discussion, but they had done a software update, and the default in the new update was to send the data every half a second.
Yes, I've encountered similar situations where it's like the encoder is just getting blasted with it. Show this now, now show this. Yeah.
Yep. And so, like, I know when we first started with our station, we had a Rivendell automation system, and we had it configured that it fired the data once every spot change. So if I played a commercial, it sent the data. If I played a song, it sent the data. It only sent it once, and that was it.
Yeah.
And that worked really well. In this particular situation, you don't have that option, but you can back it down to every 20 seconds, and that seems to play nice. So that's the other thing I was getting at, was look at your automation and maybe back the data rate down a little. I don't know, now coming out of a WorldCast Silver and feeding an Innovonics, because it's doing an off-air reception, that would be an internal thing to the 650, wouldn't it?
It would seem like if the received data at the Innovonics is good and the data coming out is not, then that would be the place you'd start looking, I would guess.
Yeah. Oh, I got another question here. William Bowen asked it, and Frank Felker had asked in the advance questions. There may be one other one there. And by the way, if Ron Castro is listening now or archived, the automation system we're talking about is the one you asked about in the advanced questions. Uh, so yeah, and I guess it's no complaint about the automation. It's just the way it is. So I guess it's okay to say their name. But yeah, if you've got a wide orbit, then go into the program manager screen, I think it is, and see what you can do to just back down the refresh rate.
Yeah.
Yeah. And I mean, they work really well, but that is a challenge. So injection level, what's good?
Well, you have to know where you're modulating, right? And this is one of the things that, in fact, one of the other must-haves that I put into the new RDS encoder was a built-in FM tuner, so that you could actually look at and check your injection level on the air. So you're looking for an injection level, and it's going to vary based on your exciter and your transmitter. You're looking for an injection level that gives you modulation of the RDS carrier of 3 to 5% on the air. There's a lot of discussion about, whether more is better. Of course, obviously, any extra modulation you spend on the RDS is modulation that you technically should be removing from your audio, or some other part of your signal to stay under your modulation caps. I've seen people running RDS injection levels as high as 7%. Couple of things: if you're going to go up that high, you want to check the RDS coverage. Ideally, you want to see the RDS data on your car radio start to get glitchy and weird right about the time the signal is fading out and being unlistenable. Means your RDS is going no further than your actual audio is.
Right.
The other thing, if your injection levels are very high, you must make sure that the RDS encoder is synchronized to your 19 kilohertz pilot. We're not talking about the phase relationship yet, but it's got to be synchronized, because if those two start drifting against each other, it can actually cause audible artifacts in the composite, what we call the birdies or the chirps.
Yeah.
You'll actually hear little high-pitched weird things in the audio if you're running too high an injection level and you're not synchronized.
And that's a really good point, because if you are running an outboard RDS generator like the automats or the Inovonics, you do need to have that pilot sample coming out of your exciter to feed that, or you're not going to have this. And
right,
so
you're either passing your whole composite signal through the RDS encoder and it's passing it out with the RDS attached, or you're giving it a sample of the composite or the 19 kilohertz that it can use for sync.
Right. And if you're running a sidechain system, you absolutely, without a doubt, need the, and I guess there's a quick question. What's the difference between a sidechain and an inline? Just in a sky level view.
Inline is by far the most typical installation. It's where you go through your audio processor, whatever your stereo generator, you get your composite signal, that goes into the RDS encoder. The RDS encoder syncs to it, adds the RDS subcarrier, and that's what comes out. So you have one coax connection from audio processor to RDS generator to transmitter. Boom, done. Sidechain requires a second input on the exciter. So your audio goes directly from the processor to the transmitter, and then you've got a separate input for the RDS carrier alone. So the RDS encoder delivers just the RDS signal, but it will also have an input, hopefully, that you can sync to a 19 kilohertz pilot sample, or you can just take a tap of the main composite and synchronize to it. But that brings the RDS in on a separate input on the exciter, as opposed to passing the whole composite signal through the RDS generator.
Right.
Just a question of taste, preference, what feels safe.
Well, and again, if you're running like AES or analog audio, that may be, a viable option. So definitely you need to look at all that. Tony Dimsdale suggests looking at it with a Diva mod monitor at different sections in the flow to see where the dropouts, and that ties into a question that, let's see, scrolling down, see the questions come in faster than I can answer. So I just sort of log them all up and then try to scroll back and forth. But Kirk Nisbet had asked if there's a low-cost receiver available that will display the pi code and other RDS parameters, and the Divas actually do that, don't they?
Yeah, I think the Diva is probably one of the lowest cost monitors that has some kind of PI function. Of course, we've got the FMMC5. There's some consumer radios even that, if you punch the right buttons on the menus, they'll show you the PI code. You know, many consumer receivers can show you the PS text, and we really haven't even talked about radio text. You know, there's that second text field in RDS, which is designated as 64 characters. That's handled a little bit differently, and is also part of what we call the RT Plus standard. But we can cover that in a minute. But yeah, so yeah, I actually had a Sony Ericsson cell phone at one point. It was one of those rotate phones that had a built-in FM RDS receiver that could show me, you know, the PS and the radio text and the PI code and the traffic announcement flags and all that stuff. So you find RDS in unexpected places sometimes.
Yeah. Oh, I'm going to hit you with a tech. So you take off your sales guy hat, put back on your tech services hat. Automat question. I monitor on an Innovonics 638. My FMB80 is reporting buffering. The site is remote, so I haven't been able to verify otherwise, but Innovonics doesn't think it's the monitor. Anything I can do on the FMB80?
Reported buffering.
And you'll get a copy of these after, so you can reach out to Joe directly as well. But
I need to talk to Joe directly on that one, get a little clarification, because I'm not quite sure I understand what the question is.
All right, so Joe, actually, Joe, if you got a microphone, you want to open it, we don't mind doing a little bit of troubleshooting online either, just because it's always fun to watch Tony squirm. But let's see, scroll down. Oh, and he doesn't have a microphone, darn it.
Okay.
Also, the Pura 275 is a good SDR monitor for a couple of $100.
There you go.
And the Diva DB 400 or 4005. So Kirk, Diva, I'll tell you what, Kirk, I'll send you an email after the fact and give you the recommendations coming in from Joe and Mark. All kinds of stuff. Folks, I appreciate the input. We definitely need all the help we can get some days. Tell me a story about radio text. Before we start, I will say that, like at our station, the one we're looking at right now, we just use the Cove FM as our PS name, and we leave that static. Right. And then the radio text, we run the artist and song title data directly from, I think we're using Playout 1 as our automation system these days. Okay. But we run that directly over IP into the transmitter, and it just rocks and rolls. Radio text itself is one of those. It's like you said, it's part of the RT Plus standard.
Right. Well, it was part of the RDS standard since day one. So the PS was the fixed 8-character name that showed on the front of the car radios. Radio text was designed for longer format messages, station slogans, artist and title information, all that kind of stuff. Specifically not displayed by default on most car radios, although lately some of the big screen multifunction entertainment display type things will show the radio text on the car radios by default. But it was designed to be sort of behind the scenes. On a lot of car radios, you have to push a button marked text or info to show the radio text in the car. Home receivers like the venerable Denons actually would show the radio text by default, and you had to push a button to see what the PS text was. So it was designed from the get-go as a 64-character, display. So it's stored in the receivers, and then how the receivers handle and display that on whatever displays they have, completely up to the receiver manufacturers. There's no real, once the 64 characters goes out, there's no real standard for what happens to it once it gets to the consumer end. Yeah. But it offered the platform for one of the later innovations in RDS, called Radio Text Plus, RT Plus. So RT Plus is one of many different ODAs, an open data application that you can do with RDS. Now, we talked about TMC, the traffic messaging channel. That's what put accident information and different things like that on the GPS maps. That is an open data application, specifically delineated in the standards. Radio Text Plus is the same way. So just like you would normally do, probably send the artist and title information and display that in the radio text field. It also includes a behind the scenes data application that tells the receiver, okay, for this song, you have this information you currently have displayed in your radio text field. The artist name begins at character 6 and ends at character 15. The song title starts at character 17 and ends at character 53. And that allows the receivers then to pluck that information and give you buttons or tags or options to look for the song on iTunes when you get back home. You can do the same thing with news headlines, with station phone numbers, with web addresses, so that if they go into an appropriate RT Plus enabled receiver, that gives you a way to call the request line just by hitting a link in the radio text message. So lots of different possibilities on what you can do with the RT Plus information, and that's a marriage of the standard text display that's been in the RDS standard since the beginning, with a little behind the scenes ODA to let the receivers know how to parse up that information and use it.
Yeah, no, that's and that kind of leads into into another question we've gotten in the offline, the advanced questions. Roy wanted to know when will we be able to commonly display album art or business logos on analog RBDS?
Oh wow! now we're jumping ahead. You're skipping ahead of the class. Now we're talking about RDS 2.
Yeah, and so the short answer, I asked the question because it was the one I had left that I had marked, but
okay.
So definitely we will get to that in a moment, but yeah, it's just it's sort of an obvious segue as we go. It's like, okay, well, I can do the 8 character. Okay, now I can do 64. Oh, I can scroll them. Look, what about pictures?
Yeah.
So
yep, natural progression.
And you'd mentioned in the RT Plus that character X to character X is denoted to this, and Y to Z is that. And that kind of segues me into this little table, the different program groups, the data groups, if you will.
So this is, so yeah, all the different data that's broadcast through RDS is separated into these different groups. There are 16 of them, and they are delineated into A and B groups. Typically, in my experience, the B groups are used only for error correction. So we focus only on the A groups. Every RDS broadcast has to broadcast at least one 0A group in their group sequence. The group sequence, obviously, you program into the RDS encoder, and it tells you, I want to broadcast this many of each type, this type of group in this sequence, right? Because you don't want to lump, say I want to do 8. Really, what you're controlling is the percentage of groups in your data broadcast. So typically, our default is 3 0A groups and 1 2A group. So that means 75% of your bandwidth, which is only about 1700 bits per second in RDS, 75% of that bandwidth is dedicated to the 0A groups, which contain the PS code. And that high percentage is there so that the PS code can refresh enough times quickly enough to get past that receiver reluctance that we talked about earlier, and get them to display the new 8 characters as quickly as you can. The 2A group carries your radio text information. That doesn't need to repeat as much because it just gradually fills in the 64 characters. And once it's done, it's done. You don't have to, it doesn't need any more 2A groups. So when you get into other open data applications and other uses of the RDS, any ODA group is going to have an application identifier. Any open data application has a number that tells the receivers what kind of data application it is and what groups to look in to find the data for that application. All that is contained in the 3A group. That defines the open data applications. There's the 4A group, which transmits the clock time, so that the time in the encoder can actually be used to set the clocks in the cars. It's also a requirement for the TMC. So if you're doing traffic messaging data, then you also have to be sending clock time as well. So there's a lot of different applications and a lot of flexibility in the open data applications. The RDS2 standard actually adds a C-type group. So it'll have 16 A's, 16 B's, and 16 C's when we get RDS2 rolling.
Very cool. Now, we were talking earlier about pilots and phasing and all this great stuff. And
Sure.
So you sent me a couple of photos, and those look like the ones in the NRSC standard, but
Yep.
yeah, it's 0 degrees, 90 degrees.
Right, exactly. So since the RDS carrier is the third harmonic of the 19 kilohertz pilot, the phase relationship will determine whether or not those two subcarriers peak together or peak in quadrature. And so you can see on the left there, that is when the RDS and the 19 kilohertz are in phase. So the 19 kilohertz and the 57 kilohertz are both peaking at exactly the same instant. And then you can see on the right when they're in quadrature, 90 degrees out of phase. And basically, it can save you a little bit of modulation, just a tiny, teeny line fraction of a percent of modulation overall.
Right.
It's important that you have them synced. But Jeff, you said you've also had some experiences where adjusting the phase between the 19 and the 57 can actually affect the quality of the reception of the RDS data in the field.
So what we've run into here and there is that depending on reflections and signal strength in general, so it's very terrain and site specific, but occasionally adjusting that can make a difference on where your stereo drops out. And I'll take as an example, if I'm driving to the office, which I haven't had to do for a good long time, I'll cover that, and sorry, Mother Nautel, but yeah, I work from my basement these days. It's a terrible, terrible gig. They just keep me in the dungeon. But so there's a big ridge between us and all of the Halifax stations, which are pretty much all on a common, well, 2 sites, but all in the same vicinity.
Right.
And so you'll be driving, and depending on your receiver, and as we all know, car stereo receivers vary from pretty good to really not. And a lot of times you'll see the stereo dropping out. And sometimes adjusting the phase with the RDS can make a slight difference in that. Now, again, it's not going to solve all the problems of the world.
Right.
But
yeah.
But definitely having the phase, and you'll notice that the one on Cove, we're a community station. We're 1,000 watts at 700 odd feet in an area where most people live within 50 feet of sea level. So for us, you know, we cover a long way, but by the time we get out 20 or 30 miles, that signal's not a lot of microvolts per meter.
Right.
So every little bit makes a difference sometimes, and without cranking up the injection level and dropping the modulation. So yeah. Mark has asked, and it's kind of a question for later, but we're pretty close to where we get to it. When do you expect car manufacturers to start implementing RDS2?
Well, there's still a couple of sections of the RDS standard to be ironed out. And I think we're fairly close to it. We've got, I think, sections 1 through 6 are done. They were planning a section 7 and 8 to deal with the US specific elements of RDS2 and then UECP and how UECP would need to be adjusted to handle RDS2. But I think, and I haven't gone back and read the progress so far, where of course our company is in you know, part of the RDS forum. We were part of the RDS forum since its beginning, so we were there writing the standard for the first RDS, and we're in there writing the standard for the second. But I haven't checked on the updates of late. But I believe that they rolled the US specific stuff in UACP into those previous 6 parts, and then there was one part left. I think I had a website up. You can go to RDS, RDS forum. It's rds.org.uk. And yeah, it says parts 7 and 8 will not exist. Parts 9 and 10 are now going to be RBDS and the Universal Encoder UECP section. So the original specifications of RDS have been maintained, but a lot of the unused or little used applications and parts of the RDS standard have been excised from RDS2, so we won't have to worry about them anymore.
Very cool. Now, flipping forward a little bit, this is where we get to talk about our new, so obviously you're not calling it the FMB 80 anymore, but
no,
what is the new one?
It's called, brilliantly, it's called the Automat RDS Encoder.
Well, that's easy to remember. Good.
I want that Automat RDS encoder. You know, we had quite a bit of discussion about the different possible names, but anyway, clean sheet, brand new design, very powerful. You know, so we got to, like I say, I got to put a couple of things in from my wish list, and there are a couple of things on there that were just, you know, part of the industry moving forward, like the RDS2 capability, the AES MPX over AES in and out. This also has the ability to drive 2 different transmitters at different levels. So if you got a main and a backup, you can use one RDS encoder for the both of them. It runs our ScriptEasy facility control software, all the communication in and out. You can send data UECP, you can send data ASCII, you can send it UDP, what have you. And you see that BNC connector on the upper left there, upper center left, that is the input for the tuner. And so we put that in there so you can actually see the RDS data that's being broadcast, which is nice.
Now, dumb question. I'm seeing some stenciling here where there are not holes. Is that for future options, or what's the story behind that?
Yeah, you never quite know. I mean, the hardware, everything's in there for RDS2, but you never know where the industry is going to go. So we've got the ability to throw in a second network connection. Architecture at a lot of broadcast sites is you've got a very locked down internal WAN or internal LAN for the station, but then you've got an external company like here is the traffic data provider for a lot of the companies or other companies that want to send data and use the behind the scenes parts of your RDS carrier for their own purposes. So maybe you have that second NIC connected to a DSL modem with a couple of pinholes through to the public internet so they can get their data through. Yeah, and of course dual power supplies is always an option.
Yeah, and I mean, there's another question from William. Do you think, will the RDS2 standard, is it being written so that current receivers would still be compatible with the station broadcasting RDS2?
Yeah, absolutely. You can move to RDS2, and we'll show the spectrum here in a little bit. You can move to RDS2, and it's backwards compatible with, so it'll still do all the RDS1 stuff compatible with RDS1 receivers. The receivers don't change. It's just the new receivers will be able to get more.
Right. So, and talking about the Elbmart and logos and stuff, and that, that's data that you could get with RDS2. If you got an original RDS1 receiver, you're not going to see that, but you'll still get the artist and song title and station ID. So the basic, and this is the config for your new box, and you've got a really good, so you got PI code number 1, but yeah, you've got a good breakdown of the critical stuff, if you will.
Right. It's like when you first pull an RDS encoder out of the box, you need to set a PI code, you need to see a PTY code. You've got we don't use them much here in the US, but the traffic program and traffic announcement flags, if they're pertinent to where you are, you got to check on those. Set where your radio text is going to be, program a group sequence if you don't like the default, alternate frequencies if you're using them. Those are the critical things. That will at least get you on the air with some sort of RDS data.
Yeah. Now, caveat about alternate frequencies, and I know especially in Europe they're used a lot for networks.
Yep.
Here, especially with translators, you theoretically could, but I've seen a lot of cases where some car receivers don't react well to them, especially on a fringe where they got to hop back and forth.
Yeah, and again, a lot of variety in what the car receiver manufacturers are allowed to do in terms of how they handle RDS and alternate frequencies. In France, in a lot of countries in Europe, I remember, driving around. I'd get the old beat up factory diesel Renault truck when I would go over there for a visit, and I'd tool around. I drove that thing all the way down to San Sebastian more times than I care to think about. But so what you do is you tune in and you find a program that you like, and that 8-character program name comes up on the display, and then you could drive from one end of the country to the other and be listening to the same program. In the meantime, your receiver, unbeknownst to you, is hopping from frequency to frequency to frequency to frequency as you drive down the road, almost like a cellular phone does, handing off calls from one cell tower to the next. And that's all based on the alternate frequency. It's a very powerful tool when it's embraced on a wide basis. So what happens is you're listening to a station, and in the background, in the data, it's saying, here are 4 other frequencies in this general area that are carrying the same program. So the receiver quietly, you don't even hear it. It's sampling those other 4 frequencies on a regular basis. And when it finds one that has a stronger signal and has the same PI code, it flips. And then it gets a list from that frequency. Here are 5 other frequencies down here that will carry the same program. And so it's constantly sniffing and constantly hopping from one frequency to the next, and it's seamless. It's like you're listening to a CD player.
So dumb question about that. The first thing that came to mind for me, the audio had to be pretty carefully synchronized.
Yes. Yeah, but not to SFN standards, right? Because it's not an SFN, it's a MFN, but still the audio has got to be synchronized within a couple hundred milliseconds, I would suppose.
Right. Yeah. I mean, you're not going to run it at a couple of seconds delay on one and not on another and expect it to work.
No. It's all got to be pretty well synced up.
Well, and that's the reason I bring that up is that may be some of the issues that we see here with it, because this is, again, not something we're used to dealing with in this part of the world as much. Now, and this is one of the things that we alluded to it earlier, because I mentioned that our latest software iteration for the VS at least, and I think for the bigger boxes, but I know the VS allows me to put the RDS data up on my front panel on my transmitter so that I can actually verify that I'm receiving the data. Because that's, as we were saying before, one of the biggest challenges. And your new box has a tuner built in.
Yeah, that was again something that our users requested, and we got to include that in the new RDS encoder. Interestingly enough, it's a standard feature in the US, but the rest of the world has to pay extra for it. So anyway, yeah. So because it's constantly the question I'm getting is what should I set my level? What should my RDS injection level be? Well, it should give you 3 to 5% modulation on the air. How do I do that? Well, if you have a mod monitor that can measure the RDS subcarrier independently, you can check it with that. If you have any mod monitor, you can kill your audio and your stereo pilot and measure what's left, and that should be just your RDS level. So if it can get the scale down to see 3 to 5%, you can do it that way. If you've got one of the tools like the Divas or the Puras or the whatever the things that we've been talking about that could give you an injection level as well. So I pushed the factory and they included this FM tuner. So frequency agile, so you can dial in your frequency or whatever else you can receive. And it gives you the injection level. It shows you the current data. It even starts counting the data groups, the RDS groups, so you can see the apportionment, how much of the bandwidth they're allocating to each of the different tasks and data groups that they're broadcasting. So very, very useful little tool to have right there built into the encoder.
And Tracy mentions that when it travels to Spain, note the alternate frequency switching may take a minute or so. The radio just goes silent. Still, it'd be a nice, I assume, feature for regional networks like public radio. And yeah, alternate frequency, again, done properly, can work really, really well.
Yeah, but I've not tried it much in Spain. I'll have to do that and see and experience slow switching.
So that's something to think about. So we talked about the bandwidth, and so everything from 57, 59 kilohertz left is what you're going to see with a conventional composite signal. That's your baseband, your left plus right, your pilot, your stereo, your left minus right, and your RDS.
Right. And then RDS centered on 57 kilohertz, and then RDS2 proposes up to 3 extra RDS subcarriers. 66.5, 71.25, and 76 kilohertz.
So my close-in SCA is going to go away if I'm trying to run RDS too.
Correct. Depending, because you have some flexibility about which of those carriers you choose to use. So if you've got a subcarrier at 67 already, then maybe you bypass that one and just use the 70, 71 and or the 76.
Right.
So it's
that's something else to. Right. It's just one other thing to be aware of as we evolve RDS2 and you start to look into that, then then something to definitely pay attention to.
So, and you get extra bandwidth because of the extra subcarriers and also because they're higher frequency. That also enhances the bandwidth availability a little. Go ahead.
Yeah, now I'm going to say we hit the top of the hour, which is, but bear with me, we have never ended. I don't think I've ever ended one on time. And typically we go 5 or 10 minutes late. I just want to warn folks and remind them that if you do have something you can jump out for, this will be archived. So you can always catch the last 10 minutes on YouTube or on our website. And, but anyway, so getting back to this. This kind of shows a good relationship too, and the levels are relative, of course, but it shows the relationship of pilot versus RDS. So that's the kind of thing that. So I'm biased because our transmitters have the composite baseband as one of the options for the user interface. And it's really nice to be able to just see that and to, at a glance, get an idea of, number one, is the signal there at all? Number two, what's the injection level?
Yep.
So what's the thing that you run into, I guess the most when when you get a call about RDS, is like, for me, that's one of the first things I do is ask to see a picture of the baseband, because I know in our box I can do that. Because it lets me know that they've actually got the RDS carriers turned on.
Yeah, yeah. That's just starting with, is it plugged in? Okay. Yeah, so that's obviously, if they're not seeing any RDS data at all on the air, that's one of the first places we'll look, is we'll try and find some way to measure the RDS level or get a look at the baseband to make sure that there's actually a 57 kilohertz subcarrier there. And if once we establish that, then we can go on to, why isn't it showing us anything? And then it could be a bogus PI code. It could be they just never bothered to program any PS or radio text data, so the receiver is displaying exactly what it's being told to display.
Right, and that kind of comes back to, I guess, one of the, I mean, the three big, not really gotchas, but the three big things I'll tend to run into. Number one is so on our boxes, each preset's individually programmed for power, frequency, and RDS. So if you set up a preset, like if you're running an N+1 system where you're backing up 3 different stations, you may or may not have totally different RDS settings for each one. You're probably not going to run the same on all of them. If you do, that's up to you. You've got the option. But I've run into situations where they'll have a main preset and a backup preset. They'll have the RDS configured in the main and forget to configure it in the backup. So they flip the backup.
Goes away.
Right. So that's item number one, RDS not, basically, like you said, is it plugged in? Because if you got an external RDS generator and it's not plugged in, there you go. Item number two is the ping test, I call it, the data network problem.
Right. So yeah, that's always when I'm trying to debug. Once we establish that there is an RDS carrier on the air, then you're trying to debug the commands coming from the automation software. So, and that falls into 2 basic categories: is the data getting there at all, and if it's getting there, then is it the correct syntax that the equipment is going to understand and interpret?
Right, and that segues into item number 3, which we run into, is the PI code not being programmed.
Right. Yeah. If there's no PI code, or if it's a PI code that flags the receivers that pay no attention to the man behind the curtain, and then it can cause the receivers to just go, okay, I won't show any RDS. That's fine.
Right. And so let's see, Lawrence had asked, the main reason for asking about using the correct PI code earlier is connected with hybrid radio, where a connected radio will switch between FM, HD, and a stream. The hybrid car radio will request a bearer code, which is used to identify and associate the services, and that requires the PI code to be correct. If it isn't, then the bearer code cannot be created, and the hybrid car radio will not work for that station. So,
wow.
Now, hybrid car radios, of course, are still very, very new and experimental, but folks, moving forward, if you've got a radio that's going to be switching between your terrestrial signal and your stream, having that PI code could be critical.
Yeah, sounds like it. If they're using that to backwards decode the call letters and find the stream that way, I would think. Well, I don't know. This is a new area for me. This dealing with the link in the stream. I'm gonna have to read up on that.
I've talked to David Layer about this more than once, but we'll have to get him on for one of our Tuesday sessions at some point and do a deep dive into hybrid radio. We've got some resources up here. There was an RDS Basics book, ebook done by Radio World a couple of years ago. We sponsored it, so I feel no shame at all in publicizing it. We got some feedback from Alan Jurison about it, and for the folks that don't know him, Alan was one of the principals involved in creating the NRSC guideline on it. So definitely one of the things Alan mentioned, and the reason I bring this up, and not just name dropping, although that's awesome too, but is that Alan is a big fan of 6, no more than 7% injection.
Right.
And again, I think, like you said earlier, it does depend on your market to some extent. Like for us, where we're the biggest thing around and there's a lot of flat terrain and not a lot of buildings, at 4% injection, my RDS drops out about the time I can't hear the audio anymore.
Right.
So it very much does vary by situation, but it is good to know. And he was the one.
Alan's one of the top RDS guys in the country. He knows his stuff.
Right. We've also got the link to the PI code calculator for the US off the NRSC standards website. And that was the one I was telling you, when you click on it, it will ask you whether this is for a full station or a translator. And you can put the translator ID in. And for situations like going back to hybrid radio in the future, that may become an issue. So do definitely pay attention to that.
No, certainly if it's coming right from the NRSC, it should be pretty accurate.
Yeah, and not to pump up any competition, but the next link is, and I've seen the article, I can't find it on their website anymore, but this is from an online library. It's the 2W.com paper on RDS basics. If you want a description of what the individual fields are from a technical perspective, it's a good book like that. And then after that, some handsome and intelligent fellow wrote an RDS primer not too long ago.
Well, no, very long ago.
2008.
2007, I think.
That's only 14, 15 years. Heck, in radio years, you're just a kid at that point. But so Tony wrote the RDS primer, and it's a great resource too. And I just got introduced to that one, and I've already read it twice. So, and the table earlier of the data groups, that was a direct lift from that. So, and then if you want the really technical reasoning behind the RDS guideline, the NRSC standard is also linked here. It is really cool because it gives you both the whens and the whys, but there's also some narrative about this was a result of some people approaching us, et cetera, and so on. So it also gives some of the backstory. It is a really interesting read if you're into that sort of thing. All right. On that point, we are 8 minutes past the top of the hour, pretty close to our usual finishing times. Top of the hour be damned. Tony, what are we missing? What any interesting things that you think we should bring up?
No, I think we covered it pretty well. You know, you gotta know your equipment, like you were saying earlier. You can't hit a weak encoder with too many commands too quickly, or it's going to go nuts. You can't update the PS text too quickly, or the receivers may not accept it. You know, keep an eye on your sync. Make sure that you're synced, especially if you're running higher RDS injection levels, particularly on a softer format like classical or talk or something that's not that's got some holes. You're going to hear some audible artifacts if you're not synced. You know, take care of your composite. Have fun.
Yeah, and over and above that, if you're putting in a new box, absolutely do not forget to program that PI code, folks.
Yeah, boy, very important.
On that note, Tony Peterle from Automat, thanks very much for being with us today. It was a lot of fun.
Happy to be with you, and hopefully this won't be the last time.
I don't think so, and hopefully we'll see each other in person in the not too distant future. On that note, folks, we are 10 minutes past the top of the hour, right on my personal schedule, if not the one on the clock. I want to thank you very much for spending an hour and a bit of your day with us, and we hope to see you next time. Have a great day now. Bye.
Take care.